What up, athletes? Let's get into this today. Today's essential question is, can I find the vertex? Can I find the vertex? All right. What I want you guys to do is we're going to use the ZPP and what we learned yesterday to sketch the graph for y equals 2x squared plus 8x plus 6 without using a table to solve it. You know, back in the day when we had to plug in all them stinking x values and solve for a bunch of y's, and maybe we got the right shape of the graph, or we'd have to go back and do it again. We're getting past that. We're putting all the stuff we've been learning for the past 4 or 5 months together, and we're getting some good math on. All right, so first of all, right away, go ahead and take a moment and write in your y-intercept. You should know it right away. Remember, there's a trick. I'll give you a hint. Think of the standard form, ax squared plus bx plus c. All right, take a minute. Go ahead and type it in the chat. What do you think the y-intercept is? Awesome. Let's take a look. Did you get it? Boom, right there. Awesome. So, the very next thing we got to do, and I got some good responses, by the way, so good job. Very next thing we got to do is we're going to need to use generic rectangles to break down, and then the zero product property to solve for the roots or the x-intercepts. So, take a moment, set up your generic rectangles, and factor this, and then we'll come back together and check it out. Don't forget, set up your generic rectangle in diamond, right? I really enjoy doing these. Kind of a nice problem solving, puzzle solving. It's just nice. Now, a question I got to ask you before you get too far in this, guys. Is there anything we can factor out to make this easier before we break it down? Think that through. Remember, just follow your steps we've been doing for the last several weeks. If you guys are doing your daily practice, this is going to become easy peasy lemon squeezy. And when you're dealing with prime numbers, right, it makes it easier because there's only one way to get certain products. Now, you can keep working on ahead. If you finish the product, feel free to start solving for the roots and even move on to graphing. Now, I'm going to give you guys a couple minutes, and we're just going to check and make sure we got our product down correctly. All right, let's check it out. What do we got here? Let's move this up just a tad. So when we work it out, we get that our product is x plus 1 times x plus 3. Now, what do I got to do to solve for the roots? Somebody type in chat, what do I got to do? Probably pause it right here and wait. Good, I got a couple of good responses. Good job. Okay. We got to set it equal to 0, right? We got to set each term equal to 0. So what am I going to have? I'm going to have x plus 1 equals 0. And minus 1, right? We get x equals negative 1. Which means, what is my first x-intercept? Negative 1, 0. Go ahead and solve for the next one, and we'll get back together in just a moment. Type in chat when you have it. What does x equal? Look what we did to get the first one. Solve for it. And go ahead and type in chat. What do you think x equals? All right, let's take a look. See how you guys did. Boom, it's -3, which means we have the intercept -3, 0. So what are we going to do? Let's graph this bad boy, and it's already pretty much labeled for us. We just got to put in our information. So this time 0, +6, so just take this up to about right here. That's why I have that nice little line there for you. And that's going to be our y-intercept, right? And then we know where our x values are at -1 and -3, so -1, 0, and -3. And so we know the parabola is coming down, goes through here somewhere, and comes back up. Boom. Not the best thing. I know I kind of bowed out here, but hey, there we go. We got our graph. Good job. So that was yesterday. Now today we're just going to add a little something extra to it. Because you know what? This is a good general shape of the graph. But what if I want the graph to be a little more exact? I talked yesterday about a line of symmetry. Remember I told you that in between the x-intercepts is this nice little line that we can draw, and it's called the line of symmetry, the LOS, right? Move that down. So there's this nice little line of symmetry, and if we were to fold it over, this graph would go over on itself. We're going to use that. So first, here's what we got to do. To find the vertex, first, identify the x value for the line of symmetry. Okay? And how did we do that? Remember we talked about it yesterday? You add the x values together and divide by 2. So in this case, my x values were -1 and, oh, I didn't circle it, but -3. So I'm going to have -1 plus -3 and divide by 2. What does that equal? -4/2 or -2. Awesome. So because of that, guys, so now I know that my line of symmetry is at x equals -2. And look, just guesstimating, I went right through -2. So boom, we're already there. Well, here's the deal, guys. If we know that the in-between value is at x equals -2, shouldn't I be able to plug that in and to the equation, the original equation, and solve for its y value as well? What? You bet your patukas, that's what we're going to do. So, for x equals, I want to kind of move this up here because we'll get back to this graph in a second. But check this out. For x equals -2, that's what we just found is our line of symmetry, right? Our line of symmetry. If you don't remember, line of symmetry. Okay, line of symmetry. That is also the x value of our vertex. And we're going to plug in that x value to the original equation, right? So remember our original equation up here? Y equals 2x² plus 8x plus 6. We're just plugging it into that. Y equals 2 times -2² plus 8 times -2 plus 6. So let's go ahead and take a minute and solve that. And find out what our y value is going to be. Don't forget, by the way, the -2 is inside the parentheses, so we square that. What's negative times negative? Awesome. Well, I've got my y value, have you? Let's give you just a moment to work on it, okay? In fact, why don't you type in the chat? I'm going to pause it right here. Go ahead and type in the chat. And let me know what your y value is. Okay, check it out. Here we go. Boom, y equals -2. Because -2² is +4, right? Because that negative's in the parentheses. And then 2 times 4 is 8. I combine my -16 and 6 to get -10, and boom, -2 equals y. So now we know the vertex is at -2, -2. Well, what are we going to do? We're going to use this information to make the above graph more accurate. So I know the vertex, or the extreme minimum of this parabola, is at -2, -2. So let's go. -2 -2 down here. And I'm going to use a pen actually to show. See how our graph, I didn't go down quite enough when I didn't know the vertex? Well, now that I know the vertex, I can be a little bit more exact. I go boom, and boom, and look at that. That is a much more accurate, and quite accurate actually, graph of our equation. So guys, this is great stuff right here. We're taking what we learned yesterday with the zero product property. We're mixing that with what we now know with the vertex, and we're making a fairly accurate graph of quadratic equations and expressions. So look down here. I want you guys to look at the quadratic expression right here, this x squared minus 2x minus 3. I want you to take a minute, find the x and y intercepts, do everything we did above, and then find the vertex and use these to graph the expression. I'm going to go ahead and pause it on my end. Let me go ahead and first, I always forget I can actually drag this up instead of just moving my paper up. All right, so there we go. Take a moment, and I want you to work through this, and then we'll come back and talk in a few minutes, but I'm going to give you several minutes to work through this. Ready, set, go. Don't forget, you know the y-intercept right away, right? And we know how to use the zero product property along with generic rectangle and diamond to find the x-intercepts. And then we just learned how to use those roots to find the x value for the line of symmetry, which is also the x value of the vertex. And we're going to plug that in and find our y value of the vertex so that we can have the coordinate of the vertex. I know that's a lot. That's a big sentence I just used. Go ahead and start. If you have questions, feel free to type them in the chat as I am answering them. Let's do this. Remember, the only way to get a negative up top is if one of your factors is negative on that diamond. Think about that. How can you use that to your advantage? Some good time. So remember, solve this down. Get your product. Zero product property tells us to set each factor equal to 0. Solve for our roots. Then you immediately have your x-intercepts. Once you have your x-intercepts, what do we do next? We got to find what's the value between them, right? How do we do that? We do that up top. You add them together and divide by 2. That gives you the line of symmetry. Plug that into the equation to get the y value of the vertex, and then we graph. you doing? Don't get stuck. Remember to type me in the chat if you have a question. Give you guys another minute or so. Probably pause it right now and then let me know in the chat. In fact, why don't you give me a thumbs up in, where you go down to participant, give me a thumbs up, check mark, whatever symbol you can give me in there, appropriate. That, or even type in the chat that says, I got this, I'm ready, Mr. Tim. And we're going to move on. All right. Okay. So let's see how we did. When I take that down, I'm going to move this up so you guys can see it. All right. I factored it out, so I just plugged it in. Right away, well, first of all, right away I know y-intercept 0, -3, because this is -3. Then I factor it, and I get the product x plus 1 times x minus 3, set it equal to 0, right? 0 product property. Set each factor equal to 0, and I solve for x equals -1 and x equals +3. So now I have the x-intercepts -1, 0 and 3, 0. To find the line of symmetry, right, or the x value of the vertex, I add the two roots together and divide by 2, which gets me 1. So I plug in a 1. And I plug it into the equation and solve that y equals -4 at x equals 1. So now I have my vertex, and let's graph it. Let's do this. Got the y-intercept of 0, -3, -1, 0 for an x-intercept, and 3, 0, and a vertex of 1, -4. Boom. Look at this. So this, and check this out, guys. If this is the vertex, it means everything, it's also the line of symmetry, right? Goes through there. Means everything reflects across it. So see this value I have right here? It's also going to be right over here. Look at that. We can even add some extra lines there. Now, boom. Let's draw this graph. And here's what's really cool. I don't know if you guys recognize this, but yesterday our lesson used this equation, x squared minus 2x minus 3. See if you don't remember, this was yesterday's. Here's the equation we used. Here's the graph we did. And let's see. It was supposed to go through 1, -4. Oh, I almost went there, but not quite. So this graph is definitely more accurate because we now know the vertex, right? So even though we can make a pretty decent graph with just the intercepts, adding in that vertex really, really hones it into a much more accurate graph. Guys, this is powerful math. This is a lot of big stuff. It's time to do some homework. I don't imagine we have much time left today. However, let's utilize what we got. If you have questions, please ask me in the chat. But without further ado, peace out.